In this lesson, we're going to learn a new hypothesis test called matched pairs. Now, up till this point, when we ran tests for two samples, even though I didn't directly tell you, we were looking at independent samples where there isn't a connection from one point to another point directly between the samples. Now, when we look at dependent samples, there is a connection from a specific one point to another specific point in the other sample. And you have to keep them together as a pair, just like when you're graphing an ordered pair on a grid, the X and the Y need to stay together. So, when we run a hypothesis test for two independent samples, we compare the means of two unrelated groups by finding the means and then we take the difference between them. Now, when we're looking at a hypothesis test for two dependent samples, which is what we're talking about, our matched pairs, we first find the difference between each pair and then conduct the test on the differences, treating them as a single sample. So the hypothesis tests are written using the mean of the differences. Now, besides different notation in the hypothesis and having to subtract the matched pairs to find the differences between one point in one sample and another point in the other sample, all the 5 steps of the hypothesis test is going to remain the same. So first, let's talk about the difference between dependent and independent, because it's important for you to be able to identify what situation you're looking at so you know what kind of test to run. So whenever you approach a hypothesis test with two samples, it's very important for you to read the problem carefully and identify if they're dependent samples or independent samples so that you know which method to use. Typically, that's one person or one thing that experiences two situations and then provides one data value for one sample and then another data value to the other sample with those separate experiences. But those two values are connected to the same person or the same thing. So that's why those two data values are connected and they're a pair. And a lot of times you'll see this in like a before or after situation, like if a researcher wants to test how students do on a test using two different study methods. So they'll help them study one way, take the test, see what that value is for their grade, and then that same student will take the test after studying the second method, and then they can compare the two grades. But those two test grades come from the same person, so that would be considered dependent. When we're looking at independent samples, there's no natural pairing between the two. So if I messed up the order of the data values in each list, the order isn't going to matter. They don't have to be paired up a certain way for it to make sense. So let's look at these examples in the definition box, and then we're going to try some examples for ourselves. A mechanic wants to determine if engine repairs improve gas mileage. They measure the gas mileage for each car before and after repairs. This is an example of dependent samples. You've got one car and they find the gas mileage before the repair. And then from the same car, they measure the gas mileage again so that they can compare. So those two values are directly related to each other. They're coming from the same object or the same person. So this example is considered dependent. Now, down here, we have an example of independent samples. A study compares the number of injuries sustained while exercising in two groups over 2 years. You have military personnel and civilians. Each group is assessed separately, and each individual belongs only to one group. This is an example of independent samples. So when we look at the first participant, in the military group, this participant had 5 injuries. When we look at the civilian group, that's a completely different person and he got 0 injuries. So there's no direct connection between this 5 and the 0. So if I wanted to jumble up these values, I could and it wouldn't matter. This 5 does not have to be paired with that 0 because they're coming from 2 different people. So down here, I have a chart so that you can see how we write the notation for dependent samples or paired samples. For the null hypothesis, we always write mu and then a little sub d and then is equal to 0. So that tells us there's no change, there's no difference. So if I subtract the 2 mu's, it's 0. Now, if I was doing a left-tailed test, the alternative hypothesis would be mu d is less than 0. A right-tailed test would be mu d is greater than 0. And a two-tailed test would be mu d is not equal to 0. So other than this notation and a different setup, there is no change in the steps. So in these next few examples, we're going to practice identifying if this is dependent or independent samples, because it's really important for you to be able to tell the difference. In example 1, it says a climate scientist monitors carbon emissions in a city before and after implementing a new green public transportation initiative. The same locations are measured twice, once before and once after the change. Is this scenario dependent or independent? So for location A, here's the before value and here's the after value. So these two values are coming from the same object or the same person. So these have a direct connection. So if I jumbled up the numbers, it's not going to make sense anymore. So these are considered dependent samples. Let's look at example 2. An education researcher compares final exam scores between students who used AI tutoring software and those who attended traditional tutoring sessions. Each student used only one method. Are the samples dependent or independent? So this statement right here, each student used only one method. That means it's not one person trying both methods to compare it for that person. These students here are different from each group. So instead of having 5 students try each method, there are 10 students, 5 that tried AI and 5 that tried traditional. So I can jumble up these numbers and it's not going to make a difference. These are independent. Example 3, a tech company surveys employee satisfaction at 2 different office locations to compare overall morale. Each employee works at only one office. Are the samples dependent or independent? So this score right here is from an employee at location X. This score right here is from a different employee at a different location because it says right here, each employee works at only one office. So there's not 5 employees that try both locations. There are 10 people altogether. So this score of 7.8 doesn't necessarily match or pair up or have a direct relationship to this 8.2. So I can jumble up those numbers and it's not going to matter. So these are independent samples. Example 4 says a fitness researcher evaluates the effectiveness of a new warm-up routine by timing athletes on a sprint before and after trying the routine. Each athlete is timed twice. This is key. Is this scenario dependent or independent? So this key sentence right here tells us that this athlete, number 1, gives us 2 times. They do it before and after. So these 2 values are coming from the same person. So these 2 have a direct relationship. So these are paired up, which means these are dependent samples.